Hi, everyone. Welcome back to Bufnagle the podcast, where we explore entertaining and enlightening discussions of the adventure of life and all things good. From science and technology to history and philosophy to leadership and success. We hope to give you a better understanding of the world and skills for everyone to pursue their own adventure. Hi, everybody. Welcome back to Bufnagle the podcast, where we talk about all things good and the pursuit of the adventure of life. I'm Zach, and we got a great show today where we're re-exploring the topic of a mission to Mars, what it would take, and how to create Martian electric water. You know, the important things. However, I can't make Martian electric water by myself, so I brought in my Martian electric water business partner, Rafe. Rafe, how are you doing today?
Zach, we are deep in the throes of incredible marketing, cross-platform product launch, just all sorts of incredible things. Zach, it's great to be here today. As usual, it's good to be doing the podcast with you. Hey, thanks to the listeners. Thanks for coming, guys. We appreciate having you here. If you are new to our podcast, thank you very much. We're going to ask you to please give us 4 episodes and see if you don't find something that resonates with you. We talk about all sorts of things, so certainly there will be something there for you. Remember, tell a friend, and you will get a free episode. We are on Apple Podcasts and Spotify, Amazon Music, Twitter, Instagram. We're everywhere, just like everybody else is everywhere. So we're just like everybody else except different. So that's a big plus. Remember, hit the little subscribe button on your podcast feed machine thing, and that helps us out quite a bit. And if you want to write us a good review, go to the Apple Podcast thing and type that in there. Give us 5 or 6, maybe 12 stars, whatever you want, and we would really appreciate that. Zach, we have, if I am not incorrect, we have a famous guest here today.
Yes, we do. We're bringing back on America's favorite rocket scientist because, well, we live in America and we like rocket scientists. So, as always, joining us when we talk about things that involve space, because I know nothing about space other than Martian electric water, is Bob. So, Bob, America's favorite rocket scientist, how are you doing?
I'm doing great today. Thanks for that introduction, Zach. I really appreciate it. You guys know I enjoy coming to visit the Bufnagle studio to record a podcast episode, and I'm happy to be here today.
Bob, last time you were on, we were discussing going to Mars, and we had the we had the realization that we felt a little underwhelmed, and we need more space stuff. My generation, which is like the tail end of the space generation, needs more space stuff. Zach needs something to look forward to, some rockets to launch and things like that. And we talked about going to Mars, and we spent a good deal of time talking about that. We developed the concept of Martian and lunar electric water. But there were some other things we wanted to make sure we hit on while we were at the end of that episode, because I think we ran out of time a little bit. So some of them were like the actual mechanics of how we do all these things, what we take with us. But you've kind of, like you always do, Bob, you kind of recenter us and get us off the tangents and back focused on these things. And there's a question that you're asking, right? Is why would we go in the first place?
Well, sure. Okay. So, the question of how do we get to Mars, right? Which is what us engineers want to solve. We want to solve the problem. How do we get to Mars? It begs the question, why would we go to Mars? Why do we go to Mars? And it's not a philosophical question. It's actually a question that drives technical choices. If I'm going just to visit for a short time, then that affects what kind of spacecraft I need to get there and get back. It affects how much stuff I bring. It affects, all sorts of decisions that have to be made in order to go to Mars. Similarly, if I'm going to stay longer, if I'm doing more than, say, flags and footprints, and I want to do something more along the lines of the the research station at the South Pole, then that's going to drive decisions, technical decisions. And certainly if we start talking about long-term habitation of Mars and colonization, again, that drives additional technical decisions to make in order to come up with a solution that will get us to Mars.
Now, you mentioned the South Pole, and one of our questions that we had last time we were on here talking about this stuff was we talked a little bit about the atmosphere of Mars and whether or not there was organic molecules floating around there. And so I've looked that up since then, and I've learned a little bit more about Mars, other than the fact that it's the next big rock over, right? The atmosphere of Mars, according to this little Wikipedia thing I'm looking at here, is 95% carbon dioxide, which is pretty nice as if they have water there as well, because then we can make fuel, and we're going to talk about that in a little bit. But there's an atmosphere there, but it's really thin, and it's really, really cold. This is like Mars is like it's like the Antarctic on a bad day.
Yes, and they have snow.
Yeah, that's right.
So, not only do they have water snow from water, they have snow from carbon dioxide, because the atmosphere, it gets cold enough near the poles that the atmosphere freezes and falls out of the sky.
So we get literally dry ice falling on you.
So literally the sky is falling.
Literally the sky is falling on Mars. And in fact, it's something, if you have a telescope, even an amateur telescope, when Mars and the Earth come close to each other, you can actually, if it's the right time of Mars's year, you can see that polar ice cap.
You can see the it's white on the top and the bottom.
The white contrasts the red of the rest of the planet.
Now, we got some questions from the last time about this whole concept of electric water, and we were rather jovial about that whole thing. But there were some questions.
It was a fun conversation, as I remember.
And it's going to eventually fund your grandkids' college, but we'll get it there. That'd be 2 generations, I think. So you can make fuel out of water. All right. And what you have to do, we talked about this a little bit, is you have to break the water apart. And I don't know I don't know what the kids are being taught these days in chemistry. You took chemistry, Zach, right? When you were in high school?
Defined take, but yes.
Yeah.
There's a class called chemistry that I went to.
But water is hydrogen and oxygen put together in a certain ratio, H2O. You got 2 H's and 1 O, and they're stuck together in a little molecule. But you can split those apart relatively simply. We used to do it with the model train controllers we had in our basement. We would take a bucket of water. We used my mom's spaghetti cooker. Sorry, Mom, I didn't tell you this yet, but we used the spaghetti cooker. And we would run one lead from the train controller into the water, and then the other one in another wire into the water. And we put some salt in there because that provides some ions and some things. And you turn the controller on, and little bubbles start coming off of the electrodes. And then one of them's an anode and one's a cathode, and I forget which one is which. But that's not water boiling. That is... one of them has hydrogen coming off of it, and the other one has oxygen coming off of it. And you can take test tubes, Bob, and you can put them, you fill them with water, and you put them over the top of the electrodes, and you collect the gas, and you got hydrogen and oxygen.
Absolutely. I absolutely did that as a kid as well. After seeing it done in chemistry class, that was one of the things I said, I want to do that at home. That's cool. And absolutely did the exact same thing.
Yeah, and so you would take this, and I forget how long it took. It took, I don't know, 20, 30 minutes to get enough in that test tube to have any action. But you could take that hydrogen then and cap the end of the test tube and then take it out of the water, and we would light it on fire and make a little explosion in the garage, and it wouldn't do much. It would just do a little pop and have a little flash of light. And
Thankfully, it didn't do much because we were using glass test tubes. So.
We were using glass test tubes in the garage right next to the lawnmower and the gas, right? So that's where we did these sorts of things. And the oxygen did what oxygen does. You take a match, you light it on fire, and then you blow it out, and then you immediately put it in the oxygen, and it flares back up again. So you can do this stuff. It's not really hard to make water into oxygen and hydrogen. And I just didn't know if anybody ever, Zach, did you guys ever do any of that stuff? You didn't ever.
No,
You guys,
I think we put baking soda into water and watch stuff happen.
vinegar, maybe.
Yeah.
Yeah, it makes it bubble. But you probably had to wear goggles and stuff, right?
Yeah.
Yeah, go figure. All right. So short legal disclaimer, don't do this at home unless you want to do it at home. Then just don't blame the buff. All right. That's what we're going to say. But you can do this relatively easily. And then if you go to Mars,
When you go to Mars.
Well, good question.
We're
Good
going
point.
to Mars.
We are going to Mars. When you get to Mars, they have the benefit in their atmosphere. There is carbon dioxide, which with your favorite chemistry set, I'm sure you can break apart. You take a C, one of those carbons, Bob, and you put 4 H's on it, and you have
Methane.
Methane. That's exactly right. And methane is used by the SpaceX people to do what?
Power their rocket engines. The current generation rocket that they're working on uses the Raptor engine uses methane as fuel.
Yeah, so I don't think it's too far off to consider the idea of using the water and the atmosphere that's on Mars as fuel. That seems like a pretty straightforward thing. But the other thing we talked about, Bob, and
well, in fact, Rafe, it's important to note that this is something that would affect what we have to bring, because if we can use the resources at Mars to make the rocket fuel we need to get back, then that's a good thing. That means we don't have to carry that fuel all the way from the Earth in order to get back. We can make our fuel and oxidizer, for that matter, our propellants. We can make those at Mars, and that has an effect all the way down the line on planning the mission. So it's very important to be able to use the resources where we're going.
Yeah, so of course that's not without equipment, right? When we did our experiments in our garages back when we were kids, we needed that spaghetti pot, we needed some water, which we could get there. We need some salt or some sort of some ions to throw in the water, and then we need power. Power, of course, is going to come from the sun through what? Solar panels, right?
Yeah, either solar panels or if you have a nuclear power generator. Those are also an option on Mars, because the farther you get away from the sun, the less effective the solar panels are. And Mars is still, solar power is still usable, but it may be desirable to have additional power sources.
Yeah, I wonder if we should probably get some real chemists and physics guys in here to determine how many calories we have to generate to get a rocket back. Are we going to have to, go live on Mars for 35 years just to get enough energy to come back home?
I would, if it were me, I would like to know that the fuel is already there before I leave to go to Mars.
That's a good point.
But that's just me.
Some
people like to live more adventurously than that.
So we can take. Is there discussion of taking nuclear power with us? We're going to put that on rockets and take it there.
That's something that I know they're looking at, small, compact nuclear power sources. But again, that's a thing that would need to be considered, at least in terms of how we do a Mars mission, why we're doing the mission, what kind of things do we want to be able to do when we're there.
Yeah, I think it's about that discussion of why we're going. Do we so the SpaceX guys, they want to colonize.
The stated purpose of SpaceX is to make humans multi-planetary, and they want to start with Mars. So it's pretty clear that that's their stated purpose, is colonizing Mars. I think before we get to the point of colonizing Mars, that a good middle ground there is probably the analogy, like I said before, to the South Pole research station. That I think there'll be a period of time that's measured in more like decades than in years, where we take that approach before we start thinking in terms of colonizing. But again, there are other people who want to do it quicker. They're in a bigger hurry. They believe that there will be people who want to go, because I mean, it's one thing to say, "Hey, I'm gonna design all this stuff so that people can go to Mars," but then you got to get people that want to go. And as we were talking earlier before the start of the show, Mars isn't exactly the most hospitable place, and it certainly isn't hospitable compared to Earth or even the South Pole.
Yeah, Mars is the kind of place where you go on vacation to the South Pole because it's better at the South Pole of the Earth, right? Yeah, so Mars we'd have to find something there that really makes it worth our while to go, other than just saying we're living there. No, this just hit me though. So Venus is out of the question, right? I mean, the idea of like, if we want to be multi-planetary, the gas giants aren't possible because they're just big balls of gas, right? Right, and then. But Venus is what? It's just too hot?
Venus is, yes, aside from being hot and having a atmosphere, the pressure of which is just crushing. The atmosphere is acidic. So far, I think the lifetime of spacecraft that have landed on Venus, of which those were done by the Russians, the lifetime is measured in minutes. So think about that.
Yeah, so it lands and it survives maybe a couple minutes.
Sends a picture back or two, makes the science measurement or two, and then it's crushed. It's crushed, corroded, destroyed, just like that.
So and the atmosphere is really high pressure because
that's a good question. I didn't look that up because I didn't think we were going to be talking about
I didn't think about that. You're the one who mentioned multi-planetary. So all right.
I didn't bring Venus up. You brought Venus up because you want to do a Venusian electric water.
That's right. That would be lemon flavored, I bet.
So right, if you're talking about multi-planetary and you're talking about a terrestrial planet, you're down to the moon, Luna, or Mars.
The Marsia.
Nope. And I'm going to call you on that because this is something you guys did in the last episode. You talked about the Mars, but I'm going to school you a little bit because
the Mars and the
you can say the moon because the moon is not a proper noun. Moon is general. Moon is a general word. The
because
moon actually has a name.
Of planets have moons.
Yes, and you can talk about Jupiter that has, I don't know, it used to have like 12 and now it has 30 or 40 or I don't know how many. I lost track.
They're just making
Saturn
moons there in Jupiter. Yeah.
Has a similar, large number of moons, and that's not even to talk about all the particles in the rings. But the moon has a name, has a proper name, just like the Earth is the Earth.
Wait. What? Do we have a name? Do we have a name? We're just the Earth.
Geo.
Oh, now you're stretching. Really?
Okay. So the moon's name is Luna.
I'll give you that.
And so when you get to things like an eclipse of the moon, that's a lunar eclipse for a reason. And Mars is the proper name of Mars. You could say that fourth planet from the sun, or you could say Mars, but you can't say, well, you can, but it's not right to say the Mars. Just say it.
But it's the Earth, and we're called Geo. See, I agree with you that is the moon is affectionately called Earth. Luna, and we are called. I don't know if we're called
more than affectionately.
So if the Martians, people living on the Mars, they say, hey, how about if we go to Geo? They don't say that. Did they say that?
I don't know.
Well, when we get there, we can ask.
We can ask when we get there. All right. So timing. All right, we talked a little bit about this, and but this still bothers me a bit. We talked. Zach says, "I know how we get to Mars. We just kind of aim the rocket ship." Zach, is that what you said?
We just aim to where Mars is going to be, and then it's going to get there when it gets there.
So we just is it that simple, Bob, to just kind of figure out where it's going and just aim the rocket there, or does the fact that we're all rotating around
that's going to factor in, obviously.
It is.
But for the most part, we're doing some aiming here. It's like playing darts. I really don't understand what the big deal is.
Well, you know what? Here's what it is, Zach. It's like playing darts.
Like playing darts. It is like playing darts if
you're on a merry-go-round
moving. Yes. And the dartboard was on a concentric merry-go-round going around, and when you threw your dart, it followed a curved path because gravity. So then it would be like darts.
Otherwise, Zach, it's exactly like darts.
Yeah. Other than that.
I don't see how I'm wrong here, so I'm just going to.
Well, I was about, before you said it's like darts, I was about to say your summary was fairly correct. You want to aim where Mars is going to be when you get there.
But
absolutely.
But that's a difficult problem because, like you said, because of the spinniness and the solar. From the soul, from the sun, the sola, whatever that is called. Soul, the sun, right? Yeah, somebody's SOL. All right, so you have to shoot the rocket has to go, like, you have to take into account the solar gravity. So the way I'm thinking about this, Bob, and help me understand, because I think we walked through this. I want to make sure I got this right.
I'd like to help you out, Rafe. Which way did you come in?
All right, thank you. So I'm gonna put. Okay, those of you following along at home, take your little pencil and take your paper and put a clock face on your paper. Okay.
Oh, this is getting fancy.
With two.
How many minutes do we have left?
In the clock, we have 60 minutes in the clock. All right, so we have the sun at the center of the clock. Okay, and you're going to draw two circles around the sun. All right, one is going to be Earth's orbit. And one is going to be
Mars's orbit.
Mars's orbit.
Mars's orbit.
Mars's orbit.
Earth's
MARS
and
apostrophe.
Mars's orbit.
Earth's Geo's orbit and Mars's orbit. And they're going to go. And the way we're going to look at them,
no matter what,
we're going to look from the north because you have to pick one direction. And when you look from the top down, from the north down, these planets are going anti-clockwise.
As opposed to counterclockwise. They're going around, not that's
clockwise.
A whole nother episode.
Yes, that's right. They're going counterclockwise around the clock face. All right, both the Earth.
That would be the right-hand rule, by the way.
That is the right-hand rule. So they're going around that way. And both planets are going around that way, and they're not in exactly the same plane, but they're pretty close. So we're just going to ignore that for the time being. We're also going to pretend that those are both circular orbits, but we know they're not.
As approximation. This is all an approximation.
Right. Now, we know that the Earth's orbit, so the Earth is going to be on that inner circle you draw. The Earth is going to go around once every year because that's how you define a year. And Mars is going to go around its orbit once every about 2 years, Bob? Give or take?
Yeah, it's not quite 2 years.
Just a little less than. Okay, but for purposes of this discussion, to keep things simple, we're going to assume.
For purposes of this, let's call it 2 years.
Let's call it 2 years.
Yep.
So, all right. So let's figure out how we have to get from the Earth to Mars. All right. So I'm going to to have these things start, I'm going to put the Earth at the 12 o'clock position on its orbit. All right. So the Earth is directly. Well, at least in my drawing here, it's directly above the sun. All right. And I'm going to put Mars at this time. I'm going to put it over here at the 9 o'clock position. So,
well, one way to think about this is actually first to say, well, how long does it take to get to Mars?
Yes.
Because actually you want to walk backwards from when you get to Mars and say, where does Mars need to be when we leave in order so that when we get there, it's where we are.
Sure. So it's and you have told me in the past in our other conversations we're looking at about 6 months of travel time,
give or take. Yeah, 6 to 9 months, again, depending on propulsion. But just to keep it simple, let's call it 6 months.
All right. So if you do that, 6 months is about a quarter of the time around for Mars.
Yep.
And it's about halfway around for the Earth.
Yep.
And if you want those guys to line up maybe at the 6 o'clock position, we're going to rewind that. We're going to start Mars at the 9 o'clock position. We're going to start Earth at the 12 o'clock position. And 6 months later, Earth is going to be down at the 6 o'clock position, and Mars is going to be down at the 6 o'clock position, right? So those two are kind of lined up. So what we have to do is we have to fire our rocket, Bob, when we are at the 12 o'clock position. And we have to aim it. You can't aim it like straight down to where Mars is going to be. You have to kind of aim it off to the left, right? In the rocket there, point the rocket to the left.
Yeah, if we aimed it straight down, we would be pointing at the sun, which wouldn't be a good idea, and we wouldn't hit the sun anyway. But that's a whole nother story.
Yeah.
We could do a whole episode on orbital mechanics. But basically, yes, we want to fire our rocket to leave Earth, and we're going to be pointing towards 9 o'clock, as it turns out, to the left. And then that will cause us to go in a nice arc between the Earth at 12 o'clock when we left and where Mars ends up being at 6 o'clock when we get there.
Right. So, and then therefore we're going to be actually Earth and Mars are going to be very close to each other, but it takes a while. It takes 6 months to get there. But as soon as once you're there, it seems to me you got if you want to hit Earth again when you leave, once you're at Mars, you have to pretty much hop off that flight, grab your bag, run through the terminal, and hop on the next flight back to Earth, because that's going to be 6 more months, right? And that by that time you're going to fire it off and you're going to hit Earth right back up at the noon o'clock position.
Yes, and
is that right?
And so give or take, that's approximately right. So you can go to Mars and spend a short time there and leave and come back. Or you've got to stay there for a lot longer. And we did touch on, I think we touched on this on the last episode. And this is why, because now if you're there for even 3 months, now you're not lined up to come back. And you can leave Mars 3 months later, and you will end up going to where Earth might be someday, but not when you get there.
So you get there, but there's no Earth there because the Earth's already left on its trip.
Somewhere around, it's somewhere around the clock there rather than at the position, that you want it to be.
So you stay pretty much either 0 hours, give or take,
sure,
maybe a couple days, all right? Or you stay there 2 years.
Something like that.
Or you stay there 4 years, something like that.
Yeah.
Right?
Yep.
Okay, that would
and that's important, and that has an effect on everything else you're going to do now, right?
Because if you're staying a long time, you need a sleeping bag or something, right? You got to bring
you need some things.
Space food sticks.
Yeah. Yep.
All right.
Space food sticks, Tang.
Yeah, and all those other things that you have. Well,
bufnagle lunar electric water, Martian electric water.
Martian electric water,
because we would make it there.
And that would make it Martian water.
Exactly.
Are Martian spices or mining or research or colonization sufficient reasoning to take the risk and spend the money to go?
That's a really interesting question. That's a very philosophical question. I didn't see that one coming.
Well, I didn't really see it either. It's
though I'm the one that suggested the why question. Why do we go?
Well, because I guess. Well, see that
there's an element of that, yes,
because we can.
And again, going back to SpaceX, they want to go because they want to make humans multi-planetary. And there's some good reasons for that. We have this one spaceship. It's a single point failure. We've had in the past big rocks that have hit the Earth, and those big rocks have caused all kinds of problems. Just ask the dinosaurs.
Yeah.
Oh
no, I hear you. But I'm thinking this. Okay, we want to be multi-planetary is what he said. Now, and you even said that colonizing the moon would suffice there, I guess, even though it's not a planet, it's a moon. Or I got that, but that's the only option is Mars. I mean, you've told us we can't do Venus. That's just not doable to do that. To hang up on Venus.
Venus is hell. Okay, let's just call it that and move on.
All right. So you can't do Venus.
We might want to, but why would you want to?
Right. So, you can't go to the gas giants. Jupiter and Saturn are out of the question. Uranus and Neptune are it is like
too cold, too far away.
Too cold. All right. And everything else is not attainable. I mean, it's like it's one thing to say you can't go around the Earth because it's too far around. You wouldn't have to, right? That was our argument with Columbus and stuff like that. It was like, they didn't want to try that because they knew it was too far. But they found out there was other stuff there. It's not like if we say, I got an idea, let's go to Neptune. We're not going to run into South America along the way. We're not going to run, right? Because we know what's there, right? Is that true? Is there any possibility there could be anything else out there?
Yeah, there's other stuff out there even farther. And I mean, there is conversation and some evidence to support the idea that there's another reasonably large planet outside past Neptune. But again, the farther you get from the sun, the colder it is, man. I mean, and it's already cold on Mars. So
that would be like our backup. Like maybe we just have like a seed storage lab or something on Mars in case we can send. But
there should be a seed storage library on the moon. There should be one on Mars. All those things. I mean, we should think in those terms of planetary. What could happen, and those are definitely things we should think of. And those are reason enough. I mean, the survival of humans is enough of a reason to go to Mars, I think.
But I guess so we could have people hanging out there in case something bad happens here, and then what? They wait and then they come back when they can.
Do
they want to come back?
That's a question for them, right? We're just going to put them there, Then, so no, I honestly, going back to where we started the conversation, back in the previous episode, where both you and I, even though we started, I mean, I grew up watching the American human space flight, the space race, Mercury, Gemini, and Apollo, the landings on the moon. I grew up watching all that, and contemporaneous with that, seeing the movie 2001: A Space Odyssey in 1968 or 1969, and thinking, well, that's our future. That's what we're doing. These are our first steps into the universe. And that was my expectation as a kid growing up in the 60s. And you came a little after that. You didn't get to watch the moon landings, but you had that same expectation. And to me, one of the reasons we've had 50 years where we haven't gone to the moon, haven't gone any farther, humans haven't gone any farther, is because that first trip, that first set of explorations to the moon came earlier than it would have come otherwise because of geopolitical reasons. We went there sooner than we would have gone otherwise because of the competition between nations. And so that's why it sat for a long time. But now I hope 50 years on, we're nearing the point where we're starting back to what should be the natural progression, that we do start to go back to the moon and we start to stay there. We do look at going to Mars and go there to stay as well. And then do whatever makes sense for the people, because it isn't going to be you and I. I'm not going to the Mars. I'm not going to the moon, sadly. I'm not going to Mars. And, but the people that choose to go, it will be for them to decide the reasons. And I hope they do it.
So I had the little, my little kid reader books, and there were rocket books, and we would go to the moon, and they're wearing space helmets and bouncing around and staying in space moon houses and stuff. And that was our expectation because we saw that. It starts with Jules Verne and ends up with, I don't know, and I don't think it concludes. It probably reaches its pinnacle and
Apollo in 2001: A Space Odyssey.
Right. That's where that's at the peak. And we were also going to have flying cars, right, in the year 2000. And so I'm wondering, do you think that's is that just us hoping and wishing and trying to get places and just kind of, is that naturally human dreaming? Do you think we were sold a false bill of goods? Did anybody you and I were kids watching that? Okay. And you saw 2001: Space Odyssey and you were like, that's going to be the future. Were there Stanley Kubrick made that movie, and do you think he thought that was going to be the future? Did the people who really knew what was going on, they were like, yeah, this is kind of fun, but it ain't going any farther? Did they know that?
Stanley Kubrick and Arthur Clarke made that movie, and Arthur Clarke wrote the book contemporaneously with working on the movie, and he said, I believe I said it in the last episode, but I'll say it again. Arthur Clarke said, the amazing thing isn't that we went to the moon. The amazing thing is that we went to the moon and we didn't go back. And so they believed it. They weren't just putting out this idea. They believed it. They believed that that's where we were going. And growing up in the 60s, yeah, it is. And, I was a kid. I wasn't an adult. But we were all watching this, thinking it was the future.
But okay, I guess I play it against the idea of the age of exploration and the discovery, at least from the perspective of the West, of the North and South American continents. There's this thing there that they had no idea it was there. All the models said it shouldn't be there. Like, holy cow. And not only, it wasn't like they went there and they found it and it was like, hey, here's a rock, and it's 75 degrees below zero, and they only have frozen water and they have dry ice falling from the sky. Let's go there. They would have been like, I'm out. Yeah, we found some stuff. I ain't going back. All right. So I'm trying to put it together with that picture and try to figure out if it lines up.
Weren't you the guy at the start of the previous episode that wanted us going to Mars? I was answering questions about how we get there, and how did we come around to be? Asking Bob, why do we go to Mars?
I want to go to Mars.
You're the one that wanted to go.
Because I fell asleep in the backseat of the car and I missed the Grand Canyon. I want to go see it, and I wanted to have it. Because you're right. There was this societal kind of energy. It was an energy. It was
amazing. It really was. I feel very fortunate I grew up in that time.
And I guess I want that. I really want that. I'd love to see the idea of going to Mars if we could figure out a way to have it not completely 100% suck, just a little bit less than hell. All right, which is Venus. We're determined that Venus is hell. So I can see that, and I'm trying to figure out if we could we do that? I kept looking. I keep having this picture in my head of the Martian movie, right, with the Matt Damon,
the Martian,
and it's how a good movie. Yeah, it's fun. It's exciting.
And how much money we spend on saving Matt Damon.
Yeah, again, thank you, Matt Damon. So, but
thanks, Hollywood.
It is so cold, and there's no atmosphere. And I read as a little kid. I read the Martian.
Well, there is, but it's carbon dioxide.
And but no, there's no pressure there. It's just, and it keeps. Apparently, it's leaking gases too, right? So it's the thing. But in the Martian Chronicles, they did this thing. If I remember right, I got to go back and reread it. But didn't they they essentially terraformed the planet, right? They at least in one of those stories, right? And they kind of they're growing crops eventually, and they're right. That's the plan. Is that even
the idea, the real Mars believers? That's what's in the back of their mind, or even in the front of their mind, is to take Mars, and with the resources it has, and terraform it so that it can be another Earth.
Now that would be
That would
something
be
to
worth
see.
going for.
Absolutely.
Yes.
Absolutely.
And that would be worth going for, and that would be something to see.
But
And someday
wow.
that might happen.
Well, and so that is the other thing that I get around is in my head is that they thought back when Columbus made the foolhardy decision to miscalculate the circumference of the Earth and sail west to get east. He happened to get lucky and smash into San Salvador
I'd
or wherever he
rather
was.
be lucky than good.
Right. But you know what? They thought no sense going that way because you're just going to die because you can't go that far. But you know what? We can go that far now. Had there not been a North America and South America there, and Columbus would have just sailed off into nothing, eventually we have progressed, and we have ships that could do that now. We have airplanes that could do that now. And so the only doubt I have in my head about saying it's just not doable is that I don't know what we'll come up with. I can't imagine that Columbus and his buddies were thinking, I know, let's make a big metal bird and put jet engines on it and fly that sucker, at 1.6 times the speed of sound or something. It's just, so you can't even conceive of where we're going on that. So I'm just wondering if there's a thing out there that I can't imagine terraforming Mars. I can't imagine anything. How could you get atmosphere to stick, get it a little bit warmer? But you know what? Stranger things have happened. So it would be interesting. 6-month journey. It's not going to be me. It's not going to be my kids. Zach, it might be your grandkids. But you never know. Bob, you never know.
Oh, I agree. And it'll be interesting to see what happens even in the near term. I hope we end up going back to the moon soon, and then from there start working on going to Mars.
I would love to see it. I'd love to see it because I'd love to be wrong. Would love to.
I mean, it's going to happen. It's a matter of when.
You think so? All right.
We have the technology. We have people who are driven to do it. It's a matter of when everything is going to come together and it's going to happen. Like you said, it might not be your generation. It might not be my generation. It might not be my kid's generation. But there is some point in human history when that's going to happen.
Yeah.
When? Who knows? But we're doing the work now to put ourselves in the position to make it be successful in the future. And that's probably the positive takeaway to take from it all. Even if it's negative 70 degrees, the sky is falling, and Rafe doesn't want to eat or whatever it is.
Potatoes. Again.
Yeah, potatoes growing on Mars. You know what? We did talk about this. We ended one of our episodes with the Vivaldi brothers, Zach, sailing out of the Mediterranean, going west, and no one ever heard from them again. And that was like 1290. And it was 200 years before Columbus did what he did. But they kept progressing, more technology, better instrumentation, more science. I just hope that they say someday, hey, listen to this old Bufnagle podcast. This one guy thinks we're never going to get to Mars. So,
or why would we want to go?
Why would we want to go? Look what we have now. So It would be remarkable. Bob, this is as usual. This is fantastic, and we love having your expertise on here and your centering wit to keep us from going off the rails.
Well, as always, I'm happy to keep you on the rails, Rafe, and I'm always happy to come by and visit the Bufnagle the podcast. Thank you.
Awesome. Well, Bob, thank you for being America's favorite rocket scientist.
It's the least I could do.
Thank you to all of our listeners for listening. Remember to go seek the good, be the good, and spread the good. Enjoy the adventure of life.